Welcome back into another video where we're going to establish up new concepts. That's now the subject of the formula. Right, so I also ask you and each one of us who have just joined us to at least first of all revisit the previous videos before you connect yourself to today's discussions. It's very worth it to do so because our discussion here is continuous. Like we are filing at completing up the entire syllabus, so please be there for all the videos which have already been highlighted in the past. Right, so here in our discussion, we'll be concentrating on the following objectives. One, we need to know how we can change the subject of the formula, which are there related to literal equations. But before anything else, we're going to define what a subject of the formula is all about. We'll define the formula and then going to know about the subject aside. So our main objectives will be there to change the subject of literal equations, change the subject that involves powers and roots, and finally, we're going to change the subject that involve logarithms. Maybe here and there additionally, we'll also have some kind of applied problems which are related to weights. Like to say, how do we apply everything about the change of the subject into the realistic life situation? Right, now let me take you into the business. We first of all going to discuss the definition of a formula. What is a formula before we look on all issues that are related to it. If you talk of a formula in mathematics, formula is simply an equation that shows the relationship between two or more variables. Right. A formula is simply an equation. So you can take a formula just like an equation that describes or shows the relationship that exists between two or more variables. Right. For example, here I have a formula like I is equal to PTR over 100. This is a formula about the interest. If you like to find the interest represented by I, you can find the value of the interest by multiplying principal times time times rate divided by 100 aside. So this is just a formula where if you look at it, we talk of I equal to PTR over 100. So here we are looking at the relationship that exists between I as a variable, PTR, and a constant which is just what? 100. So the entire of this one is referred to as what? A formula. And what have you can talk of the area represented by A, or talk of the circle, you talk of the pi r squared. Right? So here we are talking of the relationship that exists amongst the A, which is the area, this is pi, and then r squared. So the A can only be found when you multiply pi by what? Radius squared. Right, so these are examples of what we call them as what? Formulas. As you can see, these are just like what? Equations. So equations that shows the relationships between two or more variables. That's what we're talking about. You have got several examples of the equations to hand. You are checking the books and what you have been doing in the past. Right, now let us now also take note about what it means by a subject. We have known a formula. Now let us also look at the issues about the subject. If we talk of the subject with formula, what is it that we are trying to imply? A subject of the formula is just a variable that is expressed in terms of the other variables and constants. I repeat, a subject of a formula is just a variable that is expressed in terms of the other variables and constant. For example, like in here, I've got my example of a formula. As I was pointed out, the formula is just an equation. We have got I is a variable, P is a variable, T is a variable, R is a variable, and 100 is the constant. Right, so in this case, when I say I is equal to PTR over 100, here our variables I, P, R, and PT and R, and then the constant 100, they are really expressed in terms of I. So here, if you look at the variables, we be there pointing out I as the subject in this case, to say I is the one that is expressed in terms of PTR and 100. Meaning just to say, if I'd like to find the value of I can only be found by multiplying P, T, and R, then that will divide by 100. So you say I is expressed in terms of P, T, R, and the constant what? 100. So I is our subject. To say I can be found by doing A, B, C, D. Secondly, in the second formula, which also we had earlier, is equal to pi R squared. In this case, if you can look at this equation of ours, we have got A, we have got pi, we have got R squared. All these are variables. So which one is the subject? Here, if you can look at this one critically, you say that A can be found by multiplying this by this. So here, what we're trying to mean here is just like A is expressed in terms of pi and R squared. Thence, A is defined as what? Subject of the formula, defined by A is equal to pi R squared. Or you can say A is a subject of the equation, defined by A is equal to pi R what? Squared aside. So if you talk of the subject, it's more than like a variable that is there of the interest. Talking of a variable that is expressed in terms of other variables. So you talk of I, A, and what have you in all other scenarios. And more importantly, you always be able to see that, say, the subject is just a variable that is all found alone on a particular side of the equation. Here we've got several, so A is alone on the left-hand side, I is also alone on the left-hand side, so we call A and I as the subject of those formulas. Right, so having known what subject and what a formula is all about, let us also again try to understand this scenario when we talk of the change of the subject. That's what will be our discussion and the focus here, changing the subjects, what is it actually going to happen? So like from the same example we had, say I is equal to P TR over 100. Right, when we talk of now, say changing, change of a subject, what is it that we're actually meaning here? Right, like here, I is a subject. If somebody say change, it's simply just like now you have got a different one, variable in this case, that should be expressed in terms of the others. So in talk of the change of a subject simply means to say you choose a variable and then that variable you have chosen has to be expressed in terms of the other variables as it happened with the previous one. Like I is equal to PTR over 100. We say I is the subject is expressed in terms of PTR and 100. But now when you say change of the subject, it means now the subject can no longer be I, can be any one of them. It will be just like P. It can be T, it can be R. It means any one of them can also be expressed similarly as the way I is being expressed. So this is our business here that we'll be doing. So we'll be changing the subject of the formula which are there, part and parcel of the literal equation, subject of the formula of the equation which have got some powers and roots, and there where necessary we'll be going to looking at issues that will apply, issues about use of what? That's the logarithms. Right, so now let us get into the first objective where we need to change the subject of the formula that are related to literal equations. Right, so A, we'll look at changing of subjects, changing of subjects of the formula of literal equations. Equations. Right. So that is the first part. We have a subject. Now we'd like to change it. How do we change a subject? Right. So our model discussion here, we're going to focus on the means on how a subject can be changed. Not just a matter of saying here it should be a variable on this side, not that. What are the main principles that we follow each time we need to change a subject of a particular formula? Right, so let's have the examples here. Right. The first example, we are there to make the letter in the brackets the subject. Right, so we are going to make the letters of the following given formulas that are right on the board here, the subject. A, we have the first equation given like n is equal to kr squared plus 2, that is the krh. Here we need to make h as the subject. B, we have that is r is equal to q squared minus pr over that is q plus c. P, we need to make p, and then you also have c here where we need to make a certain variable as a subject. T minus w is equal to that is w, this is x squared over gx. Here in the bracket we have what? W. Right. From our discussion, these are some of the examples of the formulas, which are just like equations. Right. So still more come back in the definition of the subject. By these examples, you can be able to pinpoint, like in the first one, we have got n is equal to kr squared plus 2kr h. Our n is the subject. So n is expressed in terms of kr, h, and the 2 as a constant. In the second one, we've got r is equal to q squared minus c pr over q plus p. We have r as a subject here. It's r that is expressed in terms of the other variables. You can see them. And the last one, we have got c here, which you have got t minus c. W is equal to wx squared over gx. So here we would like just straight to make w as the subject. Here we don't have a subject as such. Like you can see on the left hand side, we have got t minus w. So here we cannot say that t minus w is the subject. No, not. But here now we may decide to make one of them. So let's just focus on those variables which are presented in the form of brackets. How do we make them as a subject? Right, solution. A, we have got n is equal to kr squared plus 2 krh. We would vary for h as the subject. Now, as I earlier indicated, and also by the presentation, how a subject is presented, you'd always see that the equation always have got two sides, left hand side and right hand side. The way the subjects have been presented here, you'll be able to see that a subject more like in the formula is found alone on a particular side of an equation. It can be on the right hand side or it can be on the what? Left hand side. Is that the way now that variable is expressed in terms of the others? Right. So here, as you can see, n is found on the left hand side, is the subject indeed expressed in terms of kr squared, 2 and h. So if you want to make that say h as the subject, we should also expect that h should be found on its own side. And then h will be defined that way as the subject, being expressed in terms of the others. Right. So now, how can we make that h to be alone on the particular side? That's our interest. Process has to be done mathematically, not just a matter of writing h on that side. Right, so the principles of maths, if we are there to make this one h to be on one side and alone, then we are there to at least get rid of all other variables and maybe talk of constants or everything that is found on that side and makes that h should be alone. So in this case, we can consider kr squared 2kr, all those variables has to be removed from that side. So mathematically, how do we remove them and leave h alone? So firstly, we can shift kr squared as the term to the left hand side where we have got n, then here now it comes in k minus k r squared. We have transferred this one is positive, here comes as a negative. So what do you have here? 2krh. Right. But now, still more. Though we have removed the kr squared to the left hand side, we are remaining with still more a term here, which is an expression, 2krh. We will not be comfortable to have that h with the 2kr. So now, what do? We need at least to remove the 2kr to have h alone. So the only way how we can have h alone on that side, you tell me the issue will be there related about what? It will be the issue about division. If we divide the coefficient of h, in this case is 2kr, we're going to have h alone. So let us try to do that. If I divide here the right hand side term, that is krh, divided by 2kr, and that should also be done on the other side here, n minus kr squared. This should also be divided by 2kr. Then on the right hand side, I'll have 2kr cancelled with the 2kr on top. As such, right hand side we're going to remain with h, and on left hand side we have got n minus kr squared over 2kr. So with this, you'll be able to see that h is alone on that side, one of the side, which is the right hand side, as earlier it was for n was alone on the left hand side. So as such, it means h now is the subject. So you can conclude that to say h is equal to n minus k r squared over 2kr. So this is the way we take it mathematically to make h as the subject. Right. Let's also get into the second example. Similarly, how do we make now what? P as the subject. At present is R, which is the subject, but now how do we make P as the subject? Expressing P in terms of the other variables. Right. I hope that you have taken note of this. So allow me to erase this one out, and then we have the solution to the second example. Second example is given as R is equal to Q squared over P R over Q plus R. What we want is P as the subject. So P is somewhere here as the numerator. It's part and parcel of the entire expression defined as Q squared minus PR. So what we want is only P alone, as it is for R. Now, what should we do? Right, so more importantly, you also have to always be able to remember what you have been doing in the past, applications of which I think can help also to come up with the mechanism on how we can make a particular variable as the subject. So like here, to make P as the subject, the first step is to at least get rid of the fraction that is containing the P as such. So how to get rid of this fraction? You go by what we have been doing in the algebraic fractions, where you need to multiply both sides by the denominator. So our denominator here is Q plus R. So what I'll do, I'll multiply R left hand side by Q plus R. Again, on the right hand side, we have Q squared minus PR over Q plus R multiplied by Q plus R. Look at that. So here, this will cancel this. And what about the left hand side? You just have to remove the brackets here. It's more like expansion. So here, since we may not be very much interested with that, but still we can do it. R times Q give us RQ. R times R give us R squared. So this side we have got Q squared minus PR. That's what we have. Now our interest is to have P as the subject. So what we're going to do, sometimes here, in order to omit the negative, because if you leave the P on this side here to have a negative, we can transfer this term here to this left hand side, and the negative will go, and then these other terms will have to go to the right-hand side. So I'll transfer this one here. It is negative. Here now it will be positive PR, while here will remain with Q squared, and then let's transfer these terms to the right-hand side because we are not interested with them. So this comes here, it will be minus RQ, and this goes that side, it will be a goes on negative R squared. So you see, that P, which was there as part and parcel of the fraction, now it is here without a fraction. But what we want is P. So to get rid of R, the issue here is about division. So we divide by R, here again we divide by R. So R and R they cancel. So what will remain if is P is equal to this. Right. So what is it that now we're going to conclude out of that? It means the value of P in this case is equal to, you can even conclude by those three dots you say right like this, 1, 2, 3. That is therefore we are talking about P here, not R. R has only been cancelled. So this one gives us Q squared. That's a minus RQ. Then what? Minus R squared divided by what? R. That's our solution. It's now P as the subject. So that's the way it goes. Just a simple subject, a simple topic as such. So try just to get note of the principles, how we do make a particular variable as a subject. Right. Lastly, let us look at the example C. This one here, more like the same. It's more like making a subject. So in this case, we don't have a subject. So we wish if we can make W as the subject. How do we do it? Similarly, the sum itself is going to tell you how best we can do it. Because what we want, we're varying here, just a matter of removing all other variables from one side and leaving that particular variable of your interest as a subject. So here we have C, T, given as minus W is equal to WX squared over GX. Right, that's what we have. So let's make now W the subject here. Right. So where is our W? We have got two W's here. This one and that one. So what we are there thinking, what we need to do, we need at least to omit the two W's and have a single one. Right. So first thing, and that is the foremost to be done. Take note of the fraction that is there. We have got WX squared over GX. Compared with T minus W. So what we do as we have done previously in the example, where we need to omit this one by multiplying every term there by the denominator of the particular fraction. So here denominator is GX. So what have we have got GX multiplied by T minus W is equal to WX squared over GX, then multiplied by GX. That's the way it goes. So this and this, they cancel. On the left-hand side, the sum itself tells you, here are brackets. So which means you need just have to expand that, and you see there's that you get out of that. So here it will be GX times T, you get a GXT, and then GX times W, it gets a minus GXW. On the right-hand side, we have got WX squared. Two W's, but we need just single, we need just a single W. So what do we do there? Let us arrange all terms which have got our variable of our interest, so that maybe we can do something and come up with a single that's a variable of such. So here, if we can see, here we have got this term has got a W, which is WX squared, and this term also have got a W. So let us arrange them together. So I've decided to transfer this one to the right hand side, and then have here on the left hand side GXT equal to WX squared. When this comes here, it will be positive to get GXW, like that. So having those together, you'll be able to tell me that the only way how I can get a single W from that is by factorization. So if you can factor out W there, you see that W is a common factor that will be of interest. But sometimes just get a common factor here, you can talk of the wx. So this one will be equal to wx into wx squared is x, plus then this one getting to that one, get what? G. Look at that. So what do we have at the end? We have got wx, open bracket, x plus j. What we want is only w, therefore have to get rid of the x plus j. So how do we do it? The same operation which was carried out in the previous examples that ended up the business, we do it. That is what? Division by the part of the expression that is not of our interest on that particular side. So here we consider x, x plus g, and here we also do the same up to the rules of the equation. So also divide x plus g, like that. So we have got this one, cancelling this one. So what we have there is only w, which tells us w is equal to this. So you can conclude here to say our w is equal to gxt over x, open brackets, x plus g. That's it. So that's it, what we have. Before I leave, can you try to work out the following exercise so that maybe you can master the concepts of the first part of the discussion? That's about changing of the subject with the formula. Right, so I have this one. I want you just to make the letter in the bracket here, the subject, as you are exercising. Right, that's one. I just want to have two. E is equal to P minus Q over PT minus QT. I want you to make P the subject. The second one, you have got I over F is equal to I over U plus I over T. You have to make F the subject. Right, otherwise, thank you very much for being together. Right, I always urge you to revise everything and also capture the previous videos by the link down here. Don't forget to do that because revision in maths is paramount. Without revision, things cannot work. Those who are joining us, we have a principle here. You first have to be connected by what we've discussed in the past. So the videos are well portrayed in the what? By the link down here. Thank you.